Alright, ladies and gentlemen, here we go. Last method of solving a system of equations. We've graphed them and we've done the substitution method. Now we're on to the elimination method. I actually call it elimination. Some people call it linear combination. Doesn't matter. If you go out there and search something else, you'll see it through linear combination. Or actually, I've also heard it called the addition subtraction algorithm. But anyways, it's called the elimination method. And let's go into an example, and I'll give you some, I think it's 6 steps or so that I'll walk you through in this example, then I'll turn you loose on one of yourself. So here we go. Okay, so here's your example. We got 5x equals 3y plus 1, and we got negative 4x plus 6y equals 10. And remember, our goal, overall goal, always, guys, is to do this. It is to find that ordered pair that actually is where these two particular things, that's ugly, where these two equations would actually intersect. So we're looking for the x and the y, that ordered pair right there, that would work in both of these particular equations, aka it's where the lines intersect. So here is step number 1 in doing these particular solving the systems of equations through the elimination method. 1, you need to arrange the variables with the like terms in columns. Now what I mean by that is this. Notice I have the 5x and negative 4x. I have the 3y and 6y, and I got the 1 and the 10. So the like terms are in columns. However, be very careful, and it's not always this way. You just have to, it's something you have to check to make sure it's true. You need to make sure that the variables, the like terms, are on the same side of the equation. Typically, we put the x's and y's on the same side of the equal sign. Like this second equation right here is written in the way that I would like to do it. So that means I need to take this 3y and algebraically get it to the left side of the equation. That means I'd have to do this. So I would subtract a 3y right there and subtract a 3y right there. So that means this first equation would go to 5x minus 3y equals 1. So that is that first equation right there. I'll rewrite the second one just so you can see it, but it looks like this. Beautiful. Okay. So there is step number 1, to make sure you have the like terms, the x's, the y's, the equals, and the actual numbers, the constants themselves, all in columns. All right, there's step 1. Step 2 is to do this. You're going to now do the actual most important step. You're going to make one of the like terms, as I like to say, opposites of each other. And you're going to say, what does that mean? Well, I'm going to need to make these x's somehow opposites. And remember, opposites would be, if this is 5x, this has to be negative 5x. If this is 17x, this has to be negative 17x. This right here is negative 3, this would have to be positive 3. Or this is 6, this has to be negative 6. Somehow we have to make these opposites of each other. And you'll see why. And how do we do that? This is why this is starred right here. It's a funky star, I know. But here's how you're going to do it. We're going to have to multiply one or sometimes both of the equations by a particular number that you can choose. You come up with a number that's going to be able to have us get opposite coefficients. So what that means is I'm going to focus on this right here, the y's, because I can easily see I can multiply this term right here by a positive 2, and that's going to make that then a negative 6, which is opposite of positive 6. So that's what I'm going to do. So let me do this. I'm going to multiply this entire the entire first equation by a 2. So the left side I'm going to multiply by 2, the right side I'm going to multiply by 2. So that means this equation right here, when I multiply it, gives me 10x. Multiply it here as well. It gives me negative 6y. Multiply this one right here. That gives me equals a 2. So I've just multiplied the 2 the whole way through. Remember, don't forget, you got to show love to the 5, show some love to the negative 3, and show some love to the 1. Don't forget to do that. It all needs love, man. So there we go. That's that. Now let me just rewrite the second equation. I haven't done anything with that second equation yet. Sometimes that happens. That's okay. But the point, again, for me multiplying by a 2 is because now I have these guys opposites of each other. And here's what's beautiful. This might look extremely confusing. I usually tell the analogy sometimes when you're driving a car, or you've been in a car, and you're in like heavy, dense fog. It's actually miserable to drive in a car when it's heavy, dense fog. But at some situations, at some point, when you're driving through this intense fog, all of a sudden you get to the top of the mountain, or you get to a valley somewhere, and it's completely crystal clear. Like it's like instant how it happens. Well, I'm going to tell you. That's what's going to happen in step number 3 to step number 4. This might look a little cloudy to you and be like, what in the world is going on? But as soon as we get through these 2 steps, you're going to be like, ah, I can see clearly now, the rain is gone. Old song. Okay, so anyways, here's step number 3. Ready? Step 3 says, I'm going to add the equations to eliminate, hence, by the way, here's where the actual method, elimination, gets its name. You are adding these 2 equations together to eliminate the actual variable that I just got opposites of each other. So, let me change colors. All kinds of colors here. So when I add 10x and negative 4x, that together gives me a 6x. When I add negative 6y and positive 6y, they eliminate. That was the whole point for doing steps 1 and 2. And then that equals 2 plus 12, which gives me, or 2 plus 10, which gives me 12. So again, if it doesn't look crystal clear now, I'm not sure it's really going to look crystal clear in step number 4. Here's step number 4. Solve for that variable. Well, that's not difficult. I just divide by 6. I divide by 6, so I get x equals 2. So here's what we got, guys. We are now halfway home because up here, let me erase this. I can erase this guy right here. Put this back up here. So now I am actually halfway home because I have my x value to be 2. So, whoa, hello. To be 2, all I need to do is find my y value. Well, that happens in step 5 and 6. So step 5 is to do this. Substitute the value that we just got here, this 2. Substitute that value back into either one. Notice it doesn't matter. Either one of the original equations. So it doesn't matter if you plug it back into this one or you plug it back into this one. But just make sure you plug it back into the original equation. Doesn't really matter. It's your choice. In fact, it might not even be bad to plug it back into both just to make sure you get the same y value, because then you'll see if you're making a mistake or not. I'm going to plug it back into the first one, so I'll do it right over here. So I'm going to have, I'll make the color the same. So I'm going to put 5, and then in parentheses, and then it's going to be equals 3y plus 1. And I'm actually taking this particular 2 and putting it in there for x, so I put a 2 right there. So now I'm going to solve this bad boy up. So that gives me 10 right here when I multiply equals 3y plus 1. I'll subtract 1 from both sides. That gives me a 9. When I divide by 3, that gives me y equals 3. So, well, that's ugly. So I get y equals a 3. So there is my other particular side of my ordered pair. Really what I'm looking at is the actual solution. So this right here is 3. So there's your answer. That right there is the solution to the system. The only other thing that you need to do, oh sorry, I actually got ahead of myself. Step 6, sorry. Step 6 is to solve for the other variable, which we just did. We solved for y. And then really the last step, and you should do this, you got to do this. Check baby, 1, 2. How do you check it, Modder? Well, you take this 2, 3, and you plug it into this equation and make sure it works. And you plug it back into this equation. Don't just plug it back into 1, because remember, when you're looking for the solution to this particular system, you're looking for that ordered pair that works in both of the actual equations. Okay? So let me roll over here now, and I'm not going to actually roll over. I'm going to go to the next slide. And on this slide, I'm going to give you an example of which I want you to copy in your notes, and I want you to do it. Here we go. So here's your example. It says 2x plus 8y equals 8. And the other equation is 3x minus 2y equals negative 16. Solve that bad boy right there and get your ever elusive ordered pair, the x and the y. Find out what that is. That is going to be your solution. I want to see what you do. Good luck with it and rock and roll. Go back through this and make sure you got all the steps, and we will practice and master these in class. Proud of y'all. We'll see you later.